Welcome to Know How Tab. Today's topic is AWS Service Control Policies. It's one of those AWS features that looks obvious on paper, but can be very confusing in actual practice. But by the end of this video, you will have a clear mental model for how these actually work. So why don't we go ahead and get started? Here is a simplified AWS setup, just 6 services, all flowing out of a tab. First, SCPs are a feature of AWS Organizations, and they define the upper limit of what IAM users and roles are allowed to do within an AWS account. They look like IAM policies, but they don't grant permissions. They set a ceiling on what existing IAM policies can actually allow. To understand how SCPs work in real life, think of them as water filters as we walk through this visual. Out of the box, we get a single SCP, the default policy called FullAWSAccess. It effectively allows everything, it sets no limits, and it cannot be edited. When working inside of AWS Organizations, at least one SCP must be attached to every object, which includes AWS accounts and OUs. And this policy also helps to overcome the concept of implicit deny, which is something that you have to understand very well. In AWS, every request is denied by default. You don't need an explicit deny to block an action. Simply the absence of an allow already blocks it by default, and that's what we mean by implicit deny. With SCPs, this implicit deny applies at the AWS account level. Even if a user's IAM policy allows an action, it only works if that action is also allowed by the SCP within the AWS account. Let's go ahead and come back to our visual. As we can see, the end result of the FullAWSAccess policy is that nothing is actually filtered out. Everything is allowed to flow through. Here's an example of the most basic setup, the root OU and the management AWS account where the organization was created. An OU is simply a container that can hold AWS accounts and other organizational units. Let's expand our organization a bit. As you may recall, at least one SCP must be attached to every OU and AWS account. The default FullAWSAccess policy removes the SCP level implicit deny, making these 6 core services eligible for IAM to grant access. You might have noticed that the management account always had these services available, and that's because SCPs do not impact the management account at all. Another point to remember is that SCPs are cumulative. All attached policies are evaluated together, and this cumulative behavior broadly applies across all applicable policies. Let's add another OU and a new AWS account to the diagram. And now we'll introduce the first way of writing SCPs, which is called a deny list. First, remember that SCPs are cumulative, and in a deny-based model, at least one SCP must include allow statements to remove the default implicit deny. Without that baseline allow, nothing can pass through. Deny-based SCPs represent the least restrictive model. They block only the services or actions you explicitly list. That also means that new AWS services and actions are automatically allowed by default, so long as they are permitted by the companion allow SCP. So here's what one looks like in practice. This SCP denies a small set of services and actions like SNS, RAM, and very specific EC2 create operations while leaving everything else eligible for IAM to grant user access. Let's come back to the diagram and apply the following SCP to the infrastructure OU to see the effect. SCPs can be attached to OUs and AWS accounts, but when you attach an SCP to an OU, its effect propagates downward to everything under that OU, just like you see in the diagram. I want you to notice something interesting here. Even though the shared services account has the FullAWSAccess SCP attached, only 4 of the 6 services are actually available for use. Now that's because we also have the deny list attached at the infrastructure OU, and that effect propagates downward from that point on. Hopefully that made sense. Let's try another example. This time we're going to apply the following SCP at the root. Go ahead and pause the video and try to guess what you think will actually happen. Are you surprised by the result? Hopefully you remember that the management account is immune to all SCPs. When we apply this very restrictive SCP at the root, all other OUs and AWS accounts became limited to only using the EC2 service. Note that we only blocked a few specific actions, not the entire EC2 service. Let's try a third example. In this case, we're going to apply the following SCP to the core apps OU, where we're specifically blocking the RAM, S3, and the SNS services. Hopefully this all makes sense now, so let's go ahead and move on to the next concept, which is the allow list. The allow list model is the most restrictive approach. Only the services and actions explicitly listed are permitted. Everything else is denied by default. And if you're thinking about implicit deny, bonus points for you. That default deny also applies to any new AWS services or actions released in the future, so access must be deliberately maintained over time. One important requirement is that the default FullAWSAccess SCP must be removed. If it remains attached, it nullifies the allow list. Multiple allow-only SCPs never conflict with each other, but if an allow list and a deny list are both present, the explicit deny always wins. In this example, the SCP only allows EC2 actions. IAM can still grant permissions, but only within EC2. Every other service is blocked at the AWS account level. Let's come back to our example and apply this allow list SCP at the Forge OU level to see what happens. It only permits the RDS service, but something curious is happening here. Can you guess what it is? I'll pause for a moment to give you time to think it through. Did you catch it? The FullAWSAccess SCP is still attached to the Forge OU, and as we discussed earlier, allow lists can never conflict with each other. They simply permit the same services multiple times. Because of that, the allow list isn't taking the effect yet. Once we remove the FullAWSAccess SCP, we can see that the intended behavior kicked in, and only RDS service is now allowed exactly as expected. One final note. FullAWSAccess applied downstream never brings anything back once it's been blocked upstream. If a service or an action is denied higher in the organization, it will never be available downstream. And if you understand what we've covered, you're now prepared to use SCPs in your environment. I always recommend reviewing the documentation, but this is how it works in a nutshell. If you enjoyed this video, consider subscribing to the channel. This is a 3-part series on service control policies. Part 2 covers the most important exceptions, and Part 3 gives you a quick way to test your understanding with real scenarios. Thanks for watching, and I'll see you in Part 2.